Hello everyone, and welcome to another episode of BMED 202. In this episode, you will be shown how to calculate reaction forces for a simply supported beam graphically. However, this time around, a UDL load is imposed on the beam. So let's begin. If you had watched one of the previous videos on UDL loads, you would realize that when solving for reaction forces on a simply supported beam, you have to firstly convert the UDL load into a point load. Only then can you take it into account when solving this problem graphically. Now, in this example here, we have a UDL load of 4 kilonewtons per meter. This is saying for every meter of space that this load takes up, a 4 kilonewton force is being exerted. So in this example, the UDL load, or the uniformly distributed load, is taking up a span of 3 meters. And as such, in order to calculate the point load equivalent, you have to multiply the UDL load, which is 4 kilonewtons per meters, by 3. Once you have done that, the equation will look like this. So it's 4 kilonewtons per meter and that is multiplied by 3 meters. And the answer will be 12 kilonewtons. The meters will cancel because this is a -1 and this is a meter. So it will cancel. So the units will be 12 kilonewtons. So once you have done that, let me copy this over here, or move this out of the way rather. I'm using this. Once you have done this, you have to now find the center point of where that point load will act, and it will act here. So then the next step would be rearranging your dimensions to facilitate the point load. So let me delete this now. I no longer need this for this application. So copy, and it will be 12 kilonewtons. So this is the space diagram that we are working with. So the new distance will be 3.5 from R1 and not 2, because we have found the center of the UDL load, and that's where the force now will act. We will take the force into consideration. Now, let's go ahead and do what we normally know how to do. We're going to draw our space diagram. Sorry, not a space diagram, our force line, which will be a part of our polar diagram, our polar polygon. So the first force is 12 newtons, and I'll represent that by drawing a 12 meter line. Then I'm going to draw a 5 meter line. Then I'm going to draw a 2 meter line. And I'm going to pick a point here that I'll use as my center point, or my pole. Then I'm going to connect all the endpoints to the pole. So this is where the 12 newton line starts. Then it goes down to here. So both points should be brought up. Then this point. So you have 3 lines here, and all the endpoints are brought up to a point. And please bear in mind, please remember that this point can be anywhere. I can even shift this point. It will not affect my answer. Once I have done this, I'm going to now proceed to extend down vertical lines from the space diagram. Once I've done that, I'm going to use these lines to make the link polygon over here. You normally start, or should start, with the uppermost line, copy it at this end, the left end, and I'm going to place it at any point on the line to the left. Where it meets the second line, that's where I'm going to stop the line, so I need to trim everything else. Then the second line, you do the same, but you are going to continue it from here. Then you trim where it touches the third line. You use this point, and if you realize it, you will see that I have missed out this one, so this should have been brought down as well. Kudos to who saw it ahead of time. So then I'm going to copy this last one here, then do the necessary trimming. Now once I've done this, then I'll proceed. I like to use another layer for this. Proceed to join this point, the ending point, to the starting point. This line will be the line that will determine the resultant forces. I'm going to copy this line, place it at the pole. Once I've placed it at the pole, I can trim this. I'm going to now measure from the top of this diagram to this line, then from this line to the end. So these are the measurements that we should now convert back to newtons. So this is 11.38 meters. It simply means that R1 is 11.38 newtons. Now, and please bear in mind that that is rounded off. That is rounded off, and it's kilonewtons, by the way. If you want the precise measurement, you have to change the precision here, the precision of your dimensions. So this is 7.62 over here. And there you have it. I have successfully calculated the reaction forces of a simply supported beam where point loads as well as UDL loads are imposed. In this case, one UDL load was imposed while 2 point loads were imposed. And what we did here was to convert the point load into a UDL load and change the distance to facilitate the transfer of this load to this load. And there you have it. I hope you learned or saw what was done and understand what was done. And please remember to share the page, like, subscribe to receive more content. Have a good day.